show up with a test to the test with a calculator. I think that's grade 10 basics. So, example, a person originally at the starting line runs west at 6.5 meters per second. What is the runner's displacement after 12 seconds? We said this. Our approach was to defic. And the first thing we asked is, hey, what are they asking me to find? What are they asking me to find here? Now, again, I mentioned yesterday, Andrea, that even though these are word problems, the physics word problems aren't too ugly because the what is part is pretty easy to figure out. What are they asking me to find? Displacement. Symbol for displacement, what letter? D. Now, displacement is the vector, so technically it should be D with a vector sign. I won't take marks off if you forget that, but I'm a nerd, I'll do it right. And I write down tie D equals question mark. Why do I do that? Because I feel better, it's no longer blank. Then again, I go through the question and I'm looking either for numbers or physicsy words. What's a physicsy word? Well, when we start looking at acceleration, often they'll say at rest or comes to a stop, and that means one of your velocities is 0, but that's coming down the pipe. So as I read through, the first thing I see is a 6.5. Is that a displacement or a velocity or a time? And how do I know? Courtney, how do I know it's a velocity? Units. Units. So let's write down v equals 6.5. It's technically a velocity because there is a direction, west, so I'll put the vector bar in front of it, on top of it. Okay. Hey, what's that 12? Because that's the next number that I see. So I'm looking for an equation that has a d, a v, and a t, and it better have the d by itself. Which one? Which one? Folks, the faster we participate, the less time you'll have, okay? I think of it that way. Now, I know on your formula sheet, Joseph, they've got the little av thing there, and they got the delta there. You know what? That's all them being very fussy. Yes, technically, time is always a change in. Yes, technically, the velocity is always in. Whatever. I just go d equals vt. Okay, now it's plug and chug. It's going to be 6.5 times 12. I can do this in my head. 6.5 times 12. 6 times 12 is 72 plus 78. Is that right? 78 what units? Meters? And this is, what? Because this is a distance. To turn it into a displacement, I better add a direction. And usually we put directions in square brackets so that you know that that's west and not watts, because you also had W for watts in Science 9. Power is measured in watt? Watts. My Science 9 kids remember that stupid joke. As do my Physics 11 and 12 kids. Ty's smiling over there. Power's measured in watt? Watts. I know. Example. Okay. What's this one asking me to find? Quick. More specific. Is it asking me to find distance or velocity or time? Okay. Good. Do this one on your own. I'll freeze the screen, see if you can get the right answer. I'm doing this in my head. Does it work out evenly? Yeah? Okay. Is it somewhere between 10 and 20? Kind of exactly like halfway between 10 and 20? Okay. I'm just trying to see if I can still do decimals in my head because I grew up without a calculator. Is it 15? 15 what? Seconds. Remember we said at the end, Units, double check, and then you can put a box around the answer if you want. I forgot to on the previous one, but I just did. By the way, ready? Put your pencils down. Nerd moment. Nerd moment. What direction was the velocity? Sorry, what direction was the displacement? What direction was the velocity? Hey, what's north divided by north? They kind of cancel, and you do get a lovely little scalar answer. Nerd moment, you don't need to know that, but I couldn't resist showing you. Anyways, keep going. Try the next one on your own. I'll do it up here. Again, DFIC. Identify what they're asking you to find. Okay? So you ready? Alex, my friend, because you guys were away. What are they asking me to find in this question? Read it to yourself. Are they asking me to find a distance, a velocity, or a time? How do you know? You're right. How do you know? Okay, so the word how long, well, how long is a weird one. It can mean, Alex? Yeah. It can mean how much time, or it can mean how long something is, like in terms of a length. But what do you see right there? Meters per second, which is a velocity. And what do you see right here? Meters, which is a, so you can also do it with a process of elimination. You can say, well, look, they gave me a velocity and a distance. I think they're asking me to find a time. So Alex, we said this. I write down t equals question mark. What's that 15? Yep. What's the 11?
Let's say distance.
Yep. On your purple formula sheet, what's the equation that has a t, a v, and a d, and also has the t by itself?
Why is that good? Wait, I'll just do it in my head.
No. Because it's going to get tougher. So you got the purple formula sheet? Okay, what's the equation that has the t by itself? They're at the bottom there. There's 3 of them in a box. And it's got a d and a v also in it, but it has the t by itself. Julie, I need you with me here, guys. I know it's a Friday. I don't care. Sorry? Okay, Julie, can you see it there in the purple box? So there's 3 equations in the box. Find the one that has the t by itself and has a d and a v in it. I'll give you a hint. More specific. Read it to me. Bottom row. See the bottom boxes there? In one of the boxes, I'm telling you, there's an equation that has a t by itself. It says t equals, and all else it has is a d and a v. Read it to me. Yes. Yep. That's what I'm looking for. Okay. Keep going, Julie. What is the distance in this question, kiddo? Julia, sorry. What is the distance in this question? Yeah, I listed it. That's why we defect. That's why I listed it. What is the distance? No, I'm not sure. It's listed there. Yep. What's the velocity? 11 divided by 15. Do that one in your head, Mr. Dueck. Well, maybe. 11 divided by 5 would be 5.5. Divided by 3 is going to be 1.78? What? Oh, I'm way off. What is it? 0. Units. Seconds. A couple more done. Turn the page. Okay. How many things are they asking me to find in this one? How many things are they asking me to find in this one? 2. You know what? There. And again, you're going, Dueck, why are you spending so much time telling us what to write? Dylan, I've learned by writing something down, Matt, kids are more relaxed, they do better. So you know what? 2 things, I'll divide my page in half. What's the first thing they're asking me to find, Matt? In this question here, read it to yourself. What's the first? You have it in front of you. You don't need to squint, but whatever. Do you have it? Do you have it in front of you? Excellent. Just making sure. What are they asking me to find, kiddo? Yep. So, and they put the av. I'll write the little av thing. Now let's look for physics and numbers. I see a 45. What's that 45? Technically a displacement, but yeah. What's that 1.3? Time in what? What are the units? Okay, this is going to either give me kilometers per hour or it's going to give me meters per second. But what I don't want to do is like meters per hour or something like that. So time is 1.3 hours. What did they want the average velocity in? What units? It said find the average velocity in. Oh, you know what? That works because this is kilometers and this is hours. We have what are called consistent units. So can you find me the equation that has the v by itself, kiddo? He's got to find it. Don't help him. Oh, and it has a d and a t in it as well? So it's going to be 45 divided by 1.3. This is going to be the answer in kilometers per hour. Okay, that's yucky enough that I'm going to do it on my calculator and store the number on my calculator. Is that what you said? 34.61 blah, 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 blah? Yep. Okay, I'll go 34.6, but I'll keep this on my calculator for future reference. By the way, I did that on purpose. Not everything is going to work out nice. Sorry. Units. Matt, what did you say this one is being measured in? Kilometers per hour. Excellent. What else did they want? In kilometers per hour and in what? So who remembers? How do I go from kilometers per hour to meters per second? It's something to do with the 3.6. Is it divide or is it times? Okay, it's divide. If you forget, remember the freeway trick that I gave you. So V is going to be 34.6 divided by 3.6. I'm going to use my answer button on my calculator, so because I have a good calculator. And I get about 9.6 meters per second. Why are both of these technically wrong? Yeah? Nope. Yeah? I found speeds. They want velocity. So let's go back and look at the question. Direction. What is the direction? North and north. Is that okay? Last one. Woohoo! This is a tricky question. Can anybody see why this question is tricky? Well, Mr. Dueck, they're saying find displacement. We've done that. Yeah, that's not what makes it tricky. Yeah.
Because one's in minutes.
Minutes. We don't have consistent units. We're going to have to do some kind of a unit conversion. Okay? I really need that back row to get a better attention span. I don't care that it's Friday last block. So, you ready, folks? Joseph, what are they asking me to find, kiddo?
They're asking you to find the distance.
So D equals question mark. What's that 480? I'm asking you. Tis. Why is the 5 a bad time? Why is it yucky? Nope. And this is where the back row was zoning out. The big problem here is that this is 5 minutes. I think I'd like to go to hours. How do I go from minutes to hours? I don't know. So you ready? I need you here, kiddo. Or I'm going to be keeping you in after school. I need you here. Whenever I have to convert units and I don't know what to do, I always go to easier numbers. Let me show you what I mean. Ready? Don't write this down, just watch. How many hours? How many hours? So here's the question. Mathematically, what would you do to change a 60 into a 1, to change 120 into a 2? Divide by 60. This is how I figure. I don't memorize this. I always go, oh, 60 minutes is 1 hour, 120 minutes is 2 hours, 180 minutes is 3 hours. I divide by 60. I can figure it out like that every time. So, to change 5 minutes, we're going to divide it by 60. It's going to be a small number. I'll keep that on my calculator. It's 0.083 repeating hours. How's that help? Joseph, what equation has the d by itself, kiddo?
D equals B.
So it's going to be 480 times 0.0833333. Actually, you know what, Matt? I've got an answer button. 480 times, answer button. And I get 40 meters? No. What units am I in here? Look at the question. This is 40 kilometers. 40 kilometers. Okay? That's a distance. It didn't want the distance. It wants the displacement. Help me out. Yeah, which is what? East. Okay. What's your homework? I gave you part 1, section 8.2 homework last class. Section 8.2 homework, this first page is what we've just been doing, and then we start going back to slopes and graphs, which is what we did before spring break. Analyzing slopes and graphs from before spring break. Remember, if you have a position versus time graph, the slope is the velocity. The slope is the velocity. Okay? So where they want the average velocity, it's going to be the slope. Now the displacement is final minus initial. I'll let you think about that. Then there's some wishy-washy stuff here as well. Some more graphs. So this is a fair bit of stuff. Let's see. Now we get into the calculating stuff, I think. Have I done stuff like this? I think I have. And then I attach the answers. The other thing I have for you is one more little practice sheet. You got all class. Shut up. So look up this one here. Come on, computer. These are velocity and distance time twisters. What you need to do by doing some calculating is decide whether each of these statements is possible, impossible, or maybe reasonable. Okay? So, is it possible for Miss Sarich to drive 225 kilometers at 90 kilometers per hour in 2.5 hours? Yes or no? And show me some supporting calculations. Is it possible for Mr. Dueck to drive 80 kilometers an hour and arrive at Kelowna in 2 hours? Is it possible for a snail to... Is it possible for Mr. Perugia? Is it possible for Mr. Perugia? Olympic dash time, Now, some of these you'll have to do some unit conversion. I gave you this in 50 kilometers per hour. Is that possible for the Olympic dash runner's velocity to be? Well, I think you have to first of all figure it out in meters per second and then convert it to kilometers per hour. I'll talk about these next class. Oh, by the way, the Heinz ketchup one, I think that is accurate. Heinz ketchup flows at about 500 centimeters every hour, in case you're wondering. And sneezes. Okay?